Good afternoon there, Year 8, Mr. Herman here, and this will be the first video tutorial for our Term 2 Week 7 lockdown. This is exercise 3C, operations with negative fractions. Learning goals for this exercise is to look into the technique of adding, subtracting, multiplying, and dividing positive and negative fractions, and to understand the rules of positive and negative numbers. The success criteria is to be able to add, subtract, multiply, and divide negative numbers. Now, how we tackle our set work is as follows. Just pretend that this right here is the whiteboard, and anything that you see within the screen, you should copy down into your notebook or your theory book. So right here, we've got the title, 3C, operations with negative fractions, and then we're going to put the date that we are looking at this video, which will be the 1st of 6th, 2021. So that will be your title and that will be your date. So in the English mathematician, in the world of math, the English mathematician named John Wallis, he invented a number line that displayed numbers extending in both the positive and negative directions. So just as we have negative integers, and remember integers is just another word for numbers, whole numbers. Just as we have negative integers, we can also have negative fractions. In fact, each positive fraction has an opposite negative fraction. Two examples are highlighted on the number line below. So right here is a number line made by John Wallis. If you can imagine here, this is a 0. Okay. And at this 0, you've got the negative numbers going to the left, and you've got the positive numbers going to the right. Now, every whole number goes across by a consistent amount, 1, 2, 3. And within here, we have half, which obviously lies in the middle of 0 and 1. And we have 2 and 2/3, which lies in between 2 and 3, and it's 2/3 of the way in. So this is 2 and 2/3. Now, in the negative world, this is pretty much going to be a mirror image of that. So obviously we've got 1 and -1, we've got 2 and -2, but we also have the mirror images of their fractions. Half, -half, 2 and 2/3, -2 and 2/3. And this works for every single fraction that has a positive form of it. There will always be a negative form of this. Also works with decimals as well, but now we're just looking into operations with negative fractions. So what we'll be looking into is applying our negative and positive rules for adding and subtracting, multiplying, dividing, but intertwining this with fractions. Can get a little bit tricky, so let's just recall the different addition and subtraction rules. So I'll just go down to our first example over here, and this is taken straight from the textbook, example 7 from exercise 3C. Just before we tackle this, when it comes to addition and subtraction, so addition and subtraction, sorry, that's just my wife in the background playing a game. When it comes to addition and subtraction, if we see two positives next to each other, let's just disregard if there's a bracket or there or not. When we see two additions together, we're going to circle them and just turn them into an addition or a plus. If we see a plus and a negative put together, we're going to circle them and we're going to turn them into negative. Conversely, if we see a negative and a positive, this is also the same as a negative, and two negatives when put together will give us a positive. I like to think of this as the love-hate poem that I heard once. Pretend that the positive is love and the negative is hate. If you love to love, you are a lover. And that makes sense. If you love to love, you are a lover. But here we see a positive and a negative put together. So this means you love to hate. And if you love to hate, That would make you a hater, wouldn't it? You love to hate. You love hating. So that makes you a hater. And this is where the negative comes from. Another way is if you hate to love. So you hate loving. You don't really like it. You just hate loving. That also makes you a hater. And lastly, if you hate to hate, if you hate hating, you're technically a lover. So I like to think of it as loving and hating. Obviously it works when you have the actual symbols right in front of you and you can see it. I thought this was a pretty funny poem when I got taught this. Anyways, the other thing we want to look into is multiplication and division. This carries the same concept as well. Instead, when it comes to a positive times a positive, this will give you a positive number. Positive times a negative will give you a negative number. And negative times a positive will give you a negative number. And negative times a negative will give you a positive number. Same thing with division as well. There we go. I've just put it right there. Same concept, but instead of multiplication, it is division. So this is just implying that if I get a positive number and I divide it by another positive number, my result will be a negative. And so on and so forth with the negatives involved as well. We're going to use these three different tables, mix with additions and subtraction, multiplication, and division fraction rules to solve different questions. So there's going to be a lot of rules and a lot of steps to take into consideration. So we can just work at this one step at a time. We'll always get the correct answer. So the first one here, this is looking at 2 plus, in bracket, minus 5/7. Now let's just disregard the brackets for now. Here we can see there's a plus and there's a minus put together. So if we circle these two, this turns into a negative because a positive and a negative, when it comes to adding and subtracting, turns into a negative. So this is just implying that this is 2/7, take away 5/7. Our denominators are the same, so we're just going to focus on a numerator. So we know it's going to be a 7. And 2 minus 5, well, this becomes -3. Remember, it's a small number, take away a bigger number. 2, take away 5, so we end up at 1, 0, -1, -2, -3. So how you write this is you put the 3, and you put the negative in front of that whole fraction, because this implies we're now in the negative spectrum. And so we're dealing with -3/7. In other words, if you had 2/7 of something, and you take away 5/7 of something of that thing, obviously you're taking away more than what's there. So you end up in the negative quadrant. Second question here, B. This is 2/3 take away, in bracket, -4/3. So disregard the brackets. There are two negatives. This turns into a positive. So this is implying that this is 2/3. It's 4/3. Denominators are the same. So it's going to be a third of some sort. 2 plus 4 will give me 6. This is an improper fraction, so we can turn this into a proper fraction. And the beauty of this one is that you're trying to find out how many 3's go into 6. This is exactly 2. And there's no fraction afterwards that tags along. So our answer just turns into 2. Next set of examples here. We've got 1/5 plus minus 1/4. Now, the denominators in this case are different. And so we need to find what the highest common factor between 5 and 4 is. In other words, if 5 were to go for a walk and it steps every 5 steps, 5, 10, 15, 20, 25, 30, 35, etc. And the number 4 did the same thing for 8, 12, 16, 20. The question is, where is our first meeting spot? In this case, it is at 20. The highest common factor is equal to 20. So to get 1/5 and 1/4, we're going to multiply this by 4 to get to 20. And we're going to multiply this by 5, and both the numerator and the denominator, to get to 20. And at the same time, we know that a positive and a negative, if we go back up here, a positive and a negative turns this into a negative. So we've multitasked our steps here. Let's just write this next step to see what we end up with. This will be 4 over 20. 1 times 4 is 4, and 5 times 4 is 20. Take away 5 over 20. So now we've got the denominators that are the same. So we know it's going to be something out of 20. 4 take away 5 is -1. So the 1 goes on the top, and our answer is -1 over 20. There's a lot of multitasking going on with this example, but provided that you know how to convert both of these fractions to have the same highest common factor, and you know that this positive and negative turns into a negative, it's actually quite simple to tackle these questions, okay? If you want to take this one step at a time, by all means you can, provided that you get the correct answer. Next example here is -7 over 3 minus, in bracket, -3 over 2/3. Now we can see that the denominators are the same, but we have got this mixed numeral. And we've got two negatives next to each other. Now there is a negative in front of this 7 over 3, but it's not associated with another sign, so we'll just leave it as is. Okay, so let's do this. Let's turn this into a -7 over 3. Let's leave this as it is. Two negatives here. What do two negatives turn into? Positive. This is plus. Now, we need to change this mixed numeral into an improper fraction, and we've already looked into this skill in our previous class. We take the whole number and multiply that by the denominator. So this is 3 times 3, which is 9. Then add the numerator, 9 plus 2, which is 11. And the denominator stays the same. So in other words, we are getting minus 7 over 3, and we're adding 11 over 3 onto this. Now you just got to be really careful. We're starting in the negative section. We're at -7, and we're going to be adding 11. So -7, add 11, and this will give us 4 over 3, which is the same as 1 and 1/3. Because 3 goes into 4 once, with 1 remaining there. So remember, with this question here, we're starting in the negative quadrant, so we're in the negative section of the number line, and we're adding 11 over 3. Okay. If you're a bit unfamiliar with your positive and negatives, you're more than welcome to use a calculator. Don't get used to it, because we won't be using it for our test. If you need it for a little bit of practice, because you're getting a bit confused with your negatives and positives, by all means you can. We've got 4 more examples here. This one is 2/3 times -4 over 5. This 2/3 is implying that it is a positive number. So we are multiplying a positive number or positive fraction by a negative fraction. A positive fraction multiplied by a negative fraction will give us a negative answer. So this right here, regardless of what the numbers end up being, this will be a negative answer. 2 times 4 gives us 8, and 3 times 5 gives us 15. Because remember, when you multiply fractions, it's always numerator multiplied by numerator, and denominator multiplied by denominator. Fairly nice and simple. This can't be simplified any further, so that's our final answer. This one here, we have a negative multiplied by a negative. This will give us a positive number. So instead of writing positive at the front, I'm just going to leave it as is, because when you leave it blank, it implies it's a positive number. This will be 6 times 3, which is 18, and 5 times 4, which is 20. Now the highest common factor between these two, between 18 and 20, is 2. 2 goes into 18, 9. And 2 goes into 20, 10. So I know that my simplified version of this is 9 over 10. Now I just realized that the highest common factor, this isn't the right acronym for it, apologies, I just backtracked here. This isn't highest common factor, this is lowest common multiple, LCM. So LCM is equal to 20, not highest common factor, that was in the previous example, it's lowest common multiple, this is equal to 20. So I'm recording this at 9:44, so obviously my brain is not with it, I'm not in teacher mode, but that's okay. Alright, last two examples, and you can solder on into the exercise questions. We've got dividing with negative fractions. Now, again with division, a negative divided by a negative will give me a positive. The only problem we run into is we have a division, so we've got to remember keep, change, flip. Keep the first fraction, change the division into a multiplication, and flip the second fraction upside down. Also, while multitasking, knowing that a negative divided by a negative gives us a positive. So our answer is going to be positive. This will be 2 over 5 multiplied by 4 over 3. Okay. Now, I can't just take away the negatives. They still are there, but I know that my answer will be a positive number. 2 times 4 is 8. 5 times 3 will give me 15. And a negative times a negative will give me a positive. Very simple. Nothing else that's needed for this. And for B, this is negative 1 1/3 divided by 3. Now, we need to make sure that we change this into an improper fraction first. So negative 1 1/3, get the denominator multiplied by the whole number. 1 times 3 is 3, plus 1, which is 4 over 3. So this is negative 4 over 3 divided by 3. Now remember, I keep change flip, keep the first one, change this into multiplication. Now we run into a bit of a scenario I haven't seen before. We need to flip 3. Now we're so used to flipping fractions. But what do you do when you need to flip a whole number? Now you just got to remember that 3, or any type of whole number, but 3 namely, can be written as 3 over 1. Because technically this means the same thing. Because 3 over 1 is just saying how many 1s go into 3? Well, that's 3. So I've manipulated this 3 to make it look like a fraction. And we are going to be flipping 3 over 1. So if we're going to flip 3 over 1, that just becomes 1/3. Now we can go ahead and multitasking our negative divided by positive. Negative divided by positive is a negative number. 4 times 1, which is 4. And 3 times 3, which is 9. So our final answer is negative 4 over 9. I try to keep this video under 20 minutes, and I sure have. A lot of questions that are involved with this. What you'll be doing is you'll be going to exercise 8. Exercise 8. Try that again. Exercise 3C. And you're going to be attempting questions 1, 2, 3, 4, and 5. But you only need to do the two left-hand side columns of these questions. You're not going to do all of them. You're just going to be focusing on all the questions. That didn't work to my favor. There we go. You're going to be working on all the questions on the 2 left-hand columns, like so. Remember, these resources can be found on Compass. So go ahead, go into Compass, check the resources, check the relevant folder, fractions, decimals, and percentages, and go ahead and download that PDF in textbook. This is the end of this video, and I'll see you in the next one.